Thanks. My name is Dini Amanda binti Bahri Zaipul and my partner Nofarida binti Zahari. So today we will discuss about application of logic in real life, which is the topic we choose is simplification of network circuits using laws of logic.
Okay, first of all, this is our content presentation. We have introduction, serial network, parallel network, the laws of logic table, questions and solutions, example of application, and summary.
Switching network or circuit can be divided two types, which are serial and parallel. To represent the network, we can use logical expression. The connector AND is used for parallel network, while for serial network, the connector OR is used. Serial network. If two switches P and Q are connected from terminal A to terminal B serially, then it is represented by P and Q. Parallel network. If two switches P and Q are connected from terminal A to terminal B in parallel, then it is represented by P or Q. So here is the laws of logic table. They are used to ensure that arguments are valid and that conclusion can be drawn in a consistent and reliable manner. Next, it is important to note that these laws, also known as logical rules, apply to all statements and propositions, regardless of the subject matter being discussed. Let's discuss about questions and solutions. Question 1. We choose statement not P and P or not Q, and here the network circuit. Solutions, as we can see here, this statement can be simplified using law of logic. First, we need to expand not P using distributive law. Next, we can apply inverse law from not P and P to false. And the last step is we just remove false so that only not P and Q are left. And here is the network circuit after we simplify the statement.
Next, for question 2, we choose question P or not P and Q. These are the circuit from the question. From question 2 also, we can simplify the expression using the law of logic. First, we use De Morgan's law. So we get P or not P or not Q. Second, we use double negative law. So we get P or not Q. Third one, we use associative law for OR. So we get P or not Q. Last but not least, we use idempotent law. So we get P or not Q. So this is the circuit for P or not Q.
Lastly, for the last question, we use statement Q and P or not Q implication to not P. We can simplify the statement to Q. How? First step is using De Morgan's law to subtract not into Q implication P. Next, we use double negation law to remove double not of Q. The third step is we need to factorize Q and P or Q and not P using distributive law so that it will be Q and P or not P. Next, we can turn P or not P into true using negation law. And the last one is using domination law so that from Q and true, it will be only Q.
These are examples of application of logic in real life. First, we have simplifying Boolean expressions. In digital electronics, Boolean expressions are used to represent the behavior of logic gates and circuits. Simplifying these expressions using Boolean algebra and logical identities can help to minimize the number of gates and reduce the complexity of a circuit. Next, we have Quine-McCluskey algorithm. This is a method for simplifying the Boolean expressions of a logic circuit by finding the essential prime implicants and then using them to find the simplest possible Boolean expression that describes the circuit's behavior. Thirdly, we have Kernow map. This is a graphical method for simplifying Boolean expressions by grouping together adjacent terms that differ by only one variable. This allows for identification and elimination of redundant terms in a Boolean expression. The fourth one, we have logic synthesis. Logic synthesis is the process of converting a high-level description of a digital circuit, such as a Boolean expression or a state machine, into a lower-level representation, such as a gate-level netlist. Logic synthesis tools use a variety of techniques, including Boolean manipulation and optimization. To simplify and optimize the circuit, for a particular technology or application. Next, we move to summary. Simplification of network circuits is a process of reducing the complexity of a circuit by minimizing the number of components and optimizing the circuit's behavior. This is achieved by using various methods of logic such as Boolean algebra, logical identities, Cohen-Mac-Klasky algorithm, Kernock maps, and logic synthesis. In conclusion, switching networks and circuits are important concepts in the field of discrete mathematics. Switching networks refer to the connections between different devices in a communication system, while circuits refer to specific switching networks that use electrical signals to transmit information. Secondly, both switching networks and circuits play a critical role in the design and implementation of modern communication systems. Not only that, switching networks and circuits allows for efficient data transfer and processing. Furthermore, in discrete mathematics, the study of switching networks and circuits involve using Boolean algebra and logic gates to analyze and optimize the performance of any system. Other than that, many modern communication systems now incorporate digital logic circuits which are based on the principles of discrete mathematics. Overall, knowledge of switching networks and circuits is important in our daily life because switching networks and circuits are essential tools for modern communication system to provide a strong foundation for understanding and improving systems such as telephone networks, data networks, and the internet. Next, the knowledge of switching networks and circuits allows engineers and technicians to optimize the performance of communication systems by analyzing the flow of data and identifying bottlenecks. Last but not least, we know that this knowledge is in high demand in many fields, including telecommunications, computer engineering, and network administration. It opens up many career opportunities for people with expertise in this field. I think that's all from my group, but before we end our presentation, I want to share one motivational quote, which is, "Success is no accident. It is work hard, perseverance, learning, studying, sacrifice, and most of all, love of what you are doing or learning to do." Thank you for listening and have a nice day.